This tutorial aims to introduce you to geometric series. Recall that every series is based on a sequence. So too is the geometric series, and we start by looking at the sequence on which a geometric series is based. So let us suppose we have given some real number x. Then we can consider the following sequence of real numbers: x to the power 0, which is 1, x to the power 1, which is just x to the power 2, x to the power 3, x to the power 4, and so on. In short, this sequence can be expressed as x to the power n for n greater or equal to 0. That means for every real number x, we can look at the sequence x to the power n for n greater or equal to 0. Let us consider a few examples. Assume we choose x to be 1. Then x to the power n equals 1 for all n greater or equal to 0. Hence our sequence x to the power n is just constantly 1. Next, let x be minus 2. Then x to the power n equals minus 2 to the power n for all n greater or equal to 0. Now the first few elements of our sequence are minus 2 to the power 0, which is 1, minus 2 to the power 1, which is minus 2, minus 2 to the power 2, which is 4, minus 2 to the power 3, which is minus 8, and so on. We can also choose x to be a half, for instance. Then x to the power n equals a half to the power n for all n greater or equal to 0, and the first few elements of our sequence are 1, a half, a quarter, 1 over 8, and so forth. Now it is time to introduce the geometric series. As we just explained, for a given real number x, we have the sequence x to the power n for n greater or equal to 0. Then the corresponding series, which always exists and for which we use the usual notation, is called the geometric series. As you know, the elements of a series are the partial sums of the underlying sequence. In our case, the underlying sequence is x to the power n with its elements 1, x, x squared, x cubed, and so forth. Therefore, the first few elements of the geometric series are 1, 1 plus x, 1 plus x squared, 1 plus x squared plus x cubed, and so on. Let us shortly go back to our examples. For x equal to 1, x to the power n is constantly 1, and the corresponding geometric series has the elements 1, 2, 3, 4, and so on. For x equal to minus 2, the first few elements in the sequence x to the power n are 1, minus 2, 4, minus 8, and so on, and thus the corresponding geometric series has the elements 1, 1 plus minus 2, which is minus 1, minus 1 plus 4, which is 3, 3 plus minus 8, which is minus 5, and so forth. Finally, for x equal to a half, the first few elements in the sequence a half to the power n are 1, a half, a quarter, 1 over 8, and so forth, and thus the corresponding geometric series has the elements 1, 1 plus a half, which is 3 over 2, 3 over 2 plus a quarter, which is 7 over 4, 7 over 4 plus 1 over 8, which is 15 over 8, and so forth. Now that we know what a geometric series is, we can investigate about its limit. In this sense, the geometric series is well understood because we know about its limit no matter which value is held by x. We look at 3 different cases, and any real number will fall into one of them. Firstly, if x is strictly between plus and minus 1, or in other words, if the absolute value of x is less than 1, then the geometric series converges, and we even know it converges to 1 over 1 minus x. Secondly, if x is greater or equal to 1, then the geometric series diverges to plus infinity. Thirdly, if x is less or equal to minus 1, then the limit of the geometric series does not exist. Back in our examples, we get the following results. If x equals 1, then we have the case where x is greater or equal to 1, and thus the limit of this geometric series is infinity. For x equal to minus 2, clearly x is less or equal to minus 1, and therefore the limit of this geometric series does not exist. Finally, for x equal to a half, the absolute value of x is less than 1, and hence this geometric series converges, and it converges to the limit 1 over 1 minus a half, which turns out to be 2.